Hello students, I hope you are doing great. Our today's question comes from electricity, that's current and electricity, a chapter in Form 3, and today we want to do one of the questions that mostly appears in exams that may give you problems. So I want us to look at a question involving Ohm's law, and remember Ohm's law states that the potential difference across a conductor is directly proportional to current flowing through that conductor when all other factors are kept constant, and such factors include pressure and temperature. So I'm going to draw that circuit very fast. These are the wires joining the resistors and the source of voltage. So we have a 4 ohm resistor, we have 6 ohm resistor, and we also have the 5 ohm resistor, and finally the 2 ohm resistors. So these are the kinds of resistors connected in different ways throughout this circuit. We have these 2 resistors connected in series, so we have a formula that we can use to calculate the total resistance when resistors are connected in series. Also we have this resistor, this one, that is in parallel with the 2 of these resistors. So when it comes to calculating the total resistance of this parallel section, we have also a different kind of formula that you can use to find that sum of resistance. And also we have this resistor, the 2 ohm, that is in series with this section. So if we are asked to find the total resistance, for instance, we must find this section first. There is the one connected in series. We also find the total one with this connected in parallel, then the whole of it we find the total resistance when connected to the 2 ohm. That is how we apply those formulas. Now let us look at this question. In the circuit shown above, determine the total resistance. The total resistance of the circuit, in fact the whole of this circuit. We are supposed to find the total resistance. Then the second question is the total current passing across this, the total current passing across this circuit, and also the voltage across 2 ohm, 5 ohm, and 4 ohm. The voltage across 2 ohm, 5 ohm, and 4 ohm. Now let us look at this. This is the way we solve this question. The first part of it is to look at this, the series part. The 4 ohm and the 6 ohm are connected in series, and the formula for this is based on the voltage. So we have the voltage at this point and voltage at this point. The sum of the voltages is given by V1 plus V2. So when they are in series, the total voltage is the sum of the individual voltages. So we use that formula. So the total voltage is V1 plus V2. That means the voltage at the 4 ohm plus the voltage at the 6 ohm. Voltage is given by current times resistance, meaning we have current flowing here and we have current flowing here. So but the current flowing here and the current flowing here, when the resistors are connected in series, the current is the same. What changes is the voltage. So applying that formula, so it is current times the total resistance will be equal to current times the 4 ohm resistance plus current times the 6 ohm resistance. But because current is the same, we factor it out, then we get resistance 1 plus the total resistance will be equal to the 4 ohm resistor plus the 6 ohm resistance, and that one will give us 10 ohms. So the total resistance in this Y section, the Y section is the series part, is 6 ohms plus 4 ohms, we get 10 ohms. So and the 10 ohms is in parallel to 5 ohms. So we also have another formula to calculate the total resistance when the resistors are connected in parallel, and that formula is given by it is given based on current. Now we say that the current flowing through the 4 ohm and the current flowing through the 6 ohm is the same. meaning the total current is the same as the current flowing through the 6 ohm and the current flowing through the 4 ohm. However, in this case, when we have a parallel connection, the current flowing at the 5 ohm will be different with the current flowing throughout this total. I hope you are getting me. So we are going to use the factor of current because current is different. So when we are looking at the total of this one, it will be, now the total resistance here is 10 ohms. Now to get the total resistance, we use the parameter of current, and the current is given by voltage divided by resistance. But when something is connected in parallel, when the circuit is connected in parallel, it means that the voltage is the same. The voltage passing through the 5 ohm and the total voltage of this point is the same. And because it's the same, we factor it out. Then we remain with 1 divided by RT is equals to 1 divided by the total resistance of this one, which is 10 ohms, plus 1 divided by this resistance, the parallel one, which is 5 ohms. We will get 3 divided by 10. And to get the resistance total, we find the reciprocal of this one. It is 1 divided by the value we get from here, and it will give us 3.33 ohms. Now 3.33 ohms is the resistance of this whole section, the series section and the parallel section. Will give us 3.33 ohm. But that's not the total resistance across the circuit, because we have the 2 ohm here. Now looking at this diagram carefully, looking at this circuit carefully, you can see that the 2 ohm resistor is in series with the total sum of these resistors, and the total sum of these resistors is 3.33 ohms. Let us now simplify this diagram. Let us draw very fast so the circuit can be simplified as shown below. So as we said, the 2 ohm is in series with the total of this one, and the total of this one is 3.33 ohms, this one. So 3.33 ohms represents the whole of this section. So, and we also have 10 volts here, of course. So the total resistance is given by 2 ohms plus 3.33 ohms. Remember, when the ohms are in series, the total resistance is given by the sum of those individual resistors, and this one gives us 5.33 ohms. So 5.33 ohms is the total resistance across this whole circuit. So student, the next part of the question was to calculate the total current. When you ask, the total current is the current passing through the entire circuit. So since we have voltage and we have the total resistance that we calculated, we can easily calculate the total current by applying this formula. So current is given by voltage divided by resistance, and remember our resistance, we found the total resistance to be 5.33 ohms, and we have voltage, of course, which is 10 volts, meaning that if we substitute these values here, we get a current of 1.876 amperes. Remember, current is measured in amperes, and there is some other sub units of current. One of the most known is milliamperes. So 1.876 is the total current passing through the entire of this circuit. So the next, the last part of this question, we were asked to calculate the voltage across the 2 ohm resistor. This one, we calculate the voltage across this 2 ohm resistor, the voltage across the 5 ohm resistor, and the voltage across the 4 ohm resistor. So the voltage across the 2 ohm resistor, the voltage across the 5 ohm and the 4 ohm resistor. How can we do that? Now let us look at this diagram. So the current, this current is passing through the 2 ohm. The whole of this current passes through the 2 ohm, meaning the voltage through this 2 ohm is given by the current times resistance. So substituting the values, we get the potential difference across the 2 ohms is 1.876 amperes times the 2 ohm, we get 3.752 volts. So 3.752 volts is the potential difference across the 2 ohm. Now the 2 ohm is in series with the sum of this one. So meaning when they are in series, the total voltage, which is 10, is given by the voltage across the 2 ohm plus the voltage across the entire of this one. So meaning that the remaining voltage that passes through the entire of this section is given by 10 ohms minus 3.752 ohms. No, 10 volts minus 3.752 volts. The remaining is the voltage that passes across the all of this one. And also remember, when the circuit is in parallel, the voltage passing through the upper one and the voltage passing through the lower one is the same, meaning the remaining volts, the remaining potential difference is the same here and is the same at the upper part. Now let us look at the voltage across the 50 ohm resistor. The voltage across the 50 ohm resistor, we said if we subtract the total voltage minus the voltage across the 2 ohm resistor, we get the remaining voltage that will be distributed across, not distributed, that will be the same at the 5 ohm and at the sum of the 4 ohm and the 6 ohm. However, at the top here, the voltage is shared. So now let us first look at the voltage across the 5 ohms. It is given by the 10 volts minus the voltage across the 2 ohm, which is 10 volts minus 3.752 volts, and this one gives you 6.248 volts. So this is the voltage across the 5 ohm. However, this is also the same voltage across the 2 of them, but this voltage is shared between the 4 ohm and the 6 ohm. The last one, the last part of the question, we were looking at the voltage across the 4 ohm resistor. The voltage across the 4 ohm resistor. Remember, in this point, when voltage is shared, the current is the same, meaning the current of the 2 of the resistors, the current passing through across the 2 resistors is the same, but it is different. When they are in parallel, the current is different. It is the voltage that is the same, but when they are in series, the voltage is different, but current is the same. That means that if we get the current of the 5 ohm, we can subtract it from the total current to get the current flowing at this point. So let us look at the current passing through the 50 ohm. So we have its potential difference, which is 6.248 volts. We multiply by the resistance, we get we divide by resistance. Remember, current is given by voltage divided by resistance. So the potential difference across the 50 ohm, the 5 ohm, is 6.248 as we calculated earlier, divided by 5 ohms, which is 1.25 amperes. So this is the current flowing through the 5 ohm. So we look at the current flowing through the 4 ohm resistor. Remember, the total current was 1.876 amperes. This was the total current that was passing here, and when they are in series, the current is the same. So the 2 ohm, in the 2 ohm, 1.876 passed through it, and it will be the same current passing through the entire of this part. However, when it reaches at this point, it is shared between the upper part and the lower part. So the lower part has taken a current of 1.25 amperes. Now what is the remaining current? It is 1.876 minus 1.25, which gives us 0.63 amperes. Now 0.63 amperes is the current passing through through the upper section. And looking at the upper section, we have the 4 ohm and the 6 ohm, and when the resistors are connected in series, the current passing through them is the same, meaning the current passing through the 4 ohm is 0.63 amperes, and the current passing through the 6 ohm is 0.63 ohms, meaning the current passing to the 4 ohm is 0.63 ohm. Now this one will help us to calculate the potential difference across the 4 ohm resistor, which is given by the current times resistance. The current is 0.63 amperes. We multiply by the resistance, which is 4 ohms, and we get 2.52 volts. Now thank you for participating in today's presentation, and make sure if you have not subscribed, you subscribe so that you can be able to get the future videos. And also like, share and comment, and also go back and watch the previous videos before.